Hello and welcome back to the channel Understanding Concepts of Physics. In case you haven't subscribed my channel yet, kindly do so and follow the rest of the videos in order to follow what we are going to do today. So today we are going to discuss about numericals on Wien's displacement law, and we'll see why our Earth is emitting most of the light in infrared region. So let's see. So just pause the video and go through the question. Okay, so in case if you have gone through this question, there is one data which is saying 280 Kelvin, that is the temperature of the earth. It's a mean temperature. Yes, somewhere it would be lower, somewhere it would be higher, but this is the mean temperature. And they're asking three questions for us. Okay, how does the curve look like of this radiation, of this temperature? Second question, what is the maximum intensity of that wavelength? What is the wavelength for which the intensity is maximum? And in which part of the electromagnetic spectrum does it lie? So this is all three questions. I'll just represent that in tabular form. So the temperature of the earth is given, shape of the curve is asked, wavelength for which the intensity is maximum is asked, and the region of that wavelength which belongs to that category. So now if you see, you have, in case if you have gone through my previous videos, wherein I have discussed about spectral distribution, and we have also discussed about Wien's displacement law, then you would not be surprised with this graph. So on the y-axis it is emissive power, that is amount of heat energy emitted per unit area per unit time, and on the x-axis we have wavelength, that is lambda. So any body, a hot body is going to emit a range of wavelengths. It doesn't have a single wavelength. It's a distribution of wavelength. And the intensity of wavelength increases and attains a maximum value. So there is a maximum value for which that wavelength is called as lambda max. Lambda max does not imply maximum wavelength. It simply implies that wavelength at which the intensity is maximum. And then gradually the intensity decreases for higher wavelengths, and this is happening for temperature equal to 280 Kelvin. Now for this is the first way of answering. The first question was shape of the curve. This is the shape of the curve which it belongs. E stands for emissive power. Everything is written. You can just pause the video in case if you wish to write it. And the second question was to find out the wavelength. So Wien's displacement law is lambda max is equal to b by t. B is displacement constant, that is Wien's constant, that is 2.897 10 raised to minus 3. Temperature is given as 280, and we are supposed to find out lambda max. So in case if you solve this, now it totally depends on your board. In case if you are able to cancel this with 28 ka table or 7 and 4, then you can do it. Otherwise you can also divide it using logarithm or calculator if your board allows so. Now lambda max is equal to, if you solve this, you will get this answer 1.035 10 raised to minus 5 meters. So this becomes your second part. Now the third part is what region does this wavelength belongs to. So I have shown you this electromagnetic spectrum. Yes, definitely you are not supposed to show this or draw this while you are solving this, but in order to just make it more clear, I have given you this electromagnetic spectrum. And on the left hand side, on this side, is long wavelength and low frequency, and wavelength and frequency are inversely related. So if the wavelength is long, the frequency would be low, and this side is short wavelength and higher frequency. So if you see, you have gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio waves. So the frequency is increasing, going down as you go from gamma to radio waves, and the wavelength is increasing as you go down from gamma to radio waves. So this is what it is. I mean, you can just pause this and have a go at it to understand what it is. Our normal eye is only able to see this colors of light, that is the visible light. The rest of the colors, like this part and this part, is not visible to normal eye. For detecting those rays, we need special detectors to find it. However, our eyes is more suitable for this 7 colors visible light. Now if you see, our answer is coming out to be 1.035 10 raised to 5. So this is very near to 1. So this will take as almost equal to 1. And 10 raised to minus 5 is coming somewhere at this point, 10 raised to minus 5. And this 10 raised to minus 5 belongs to infrared region. So the region of wavelength belongs to infrared region. So our Earth is emitting a lot of waves. It is emitting a range of waves. It's a distribution of waves, but the maximum intensity is of infrared. Yes, there are higher wavelengths. Yes, there are lower wavelengths as well. But the maximum intensity is of infrared radiation because Earth's mean temperature is considered to be 280 as of now. Okay. So this ends today's video. Thank you so much for watching. Subscribe the channel in case you haven't done so, and follow up other videos in order to understand more. Bye.